Hello class, here we are at lesson 5.0b, and today we are going to take a look at warm-ups. So please pause the video, try these warm-ups, and then press unpause and we'll check the answers out. So pause the video, pause. Okay, welcome back class. Hopefully you had a chance to do these questions and you pause the video, and what we're going to do is take a look at taking them up. And then we're going to do some bit more review today, and then I promise you on the last page I'm going to show you something new today. Okay, so for those who are saying, Miss R, this algebra is pretty easy, I remember it from last year, I promise you we're going to learn something new today at the end, okay? So just stay with me. So what we learned last day, folks, is whenever you have integer laws, you need to collect or simplify them before you can collect like terms. So we're going to take a look here at, and you know what, folks, let me just see if I can get my line to be a little thicker, because somehow it seems to be pretty thin. Let's just see if it'll work if I go like this. Okay. Hopefully this will be a little thicker. All right. Let's see. Maybe not. A lot. We'll try to see if I can figure that out for next lesson. All right. So what we're going to do, folks, is we've got to simplify, as I mentioned, this expression here. Simplify these signs here. So we're going to leave the other terms except for the ones that need to be reduced. Okay, so a positive times a negative is a negative. Okay, now what we're going to do, now that we've done our bedmass part in terms of multiplication, now we can actually collect like terms, which is add or subtract. So let's do the highest power first. So we've got negative 5w squared plus 2w squared should be negative 2w squared, and collect your w, should it be minus 4w. All right, taking a look, ladies and gentlemen, at the second example here. What you need to do is do distributive law, so you multiply through. Okay. For the first one, so it's going to be negative 2a minus 2b. Then we're going to realize this is just a positive 1, so just drop the brackets. So plus 8 plus 3b. And here, ladies and gentlemen, it's a negative sign, so it's going to change the signs in the brackets. We've got a negative 5b and a plus a. Okay, we're going to collect like terms, folks, but hopefully you notice some things here. When we take a look at collecting like terms, take a look at the a's. So we've got lots of a terms. We want to make sure that we include them. Okay, because there's a lot of terms here. So what's negative 2a plus a is negative a. You might want to cross them out or underline them so you know you've included them. The b's is going to be plus, sorry, my fault. There's 3 b's. That's what I was having trouble with. So take a look there. So we're going to have plus 1 minus 5, which is minus 4b. And then collect our constant term as all by itself. Okay? And again, those are all different terms, so you can't add or subtract them. For the second one, ladies and gentlemen, wherever you see two signs side by side, you're going to reduce it. Now, ladies and gentlemen, this might be bothering people. Although there's no sign in here, it's understood to be positive. Okay? Otherwise, it'd have a negative sign in there. So you're just going to simply reduce the brackets there. So it's going to be negative 6f squared g plus 4f minus 2 g squared f. Now let's put that in alphabetical order, folks, because f g squared is going to help us. Okay? Watch your integer laws here. So negative 8 f squared g squared and plus 12. Watch here again. It's gf squared. It should be f squared g. If you put them in alphabetical order, then you're going to notice a pattern here. Negative times a negative is a positive 3f. By putting them in alphabetical order, you will notice that you have some like terms here that you wouldn't have if you didn't put them in like terms. So taking a look, ladies and gentlemen, you need to look for f squared g's, and that's these two. So we're going to collect like terms. So that's going to be 6f squared g. Take a look at our f's. Our f's, we've got two f terms, so that's going to be plus 7f. And then the other two are not like terms, so we are going to put down here negative 2fg squared minus 6f squared gf. Now, here's MSR. These aren't in order, but we only worry about the order, degree order, when you have one variable. Here we got two variables, so I'm not so worried about it, okay? We don't try to put them in order. Okay, out of curiosity for those advanced learners, here's your highest powered exponent because there's a 2 and a 2, which would mean a degree of 4 because you would add them up. Okay, so just if you're looking for grade 11 or 12 stuff in advancement, that's how that works. All right, last one. Evaluate the following if C equals -2 and D equals 3. Make sure you remember to simplify first. Then substitute. Okay. All right, so let's do some distributive law first. We got -15 plus 10C minus 20D. That's the first distributive law. Now the second one's going to be plus 10D minus 14 minus 20C. Collect like terms. So collect your C's, so it's going to be -10C. Collect your D's, minus 10D, and minus your constant, which is constants, which are -29. Now you're going to sub in C equals -12 and D equals 3. So it's going to be -10 times -2 minus 10 times 3 minus 29. What does that equal? 20 minus 30 minus 29. Okay. And what does this equal, ladies and gentlemen? -39. All right. Now that's our warm-up, folks. If you need some help, please come see me. Now we're going to get into the lesson. Okay, so for multiplying and dividing today, we've got to remember that we're going to break it down into 3 parts. The sign, which is your integer laws. Okay, numerical coefficients, which is just reducing to like lowest terms, and your variables with exponents. And we're going to have to remember our variable or exponent laws when we're multiplying and dividing. Okay, so let's just quickly review our multiplication law for exponents. When multiplying powers with the same base, we add the exponents. Okay, so look here at this diagram. M to the A times M to the B equals M to the A plus B. All right, and we're going to try some examples here. So it says number 1, simplify, use distributive law for D and E. Okay, so we've been practicing that. You may want to break it down to its 3 parts. So let's take a look at the sign. A positive times a negative is a negative. Do your coefficients next. 4 times 3 is 12. And then the letters are just going to be x times y, which is xy. All right, let's try the next one. A positive times a negative is a negative, but a negative times another negative is a positive. So there's our signs. We'll cancel to be positive. The numerical coefficients, we just ignore the sign on that, okay? So it's going to be 5 times 3 is 15 times 2 is 30. Okay, now we take a look at our variables and remember our exponent laws here. So we've got r to the power of 1 times r to the power of 2, which is r cubed. And let's take a look at s. So we've got s to the power of 1 plus 2 is 3 plus 1 is 4. Okay? Remember, you add the exponents when you have the same base. All right, you might need the calculator for this one, folks. Negative times a positive is a negative. 2.3 times 4.5, and your calculator is 10.35. I don't know that without using a calculator. Please don't pretend that I know that. I have to use a calculator as well. Okay, then we take a look at our variables. So we're going to have g to the power of 7 and h to the power of 5. All right, now we're going to do distributive law where we have a variable out front. So it's going to be a little harder. Okay, so again, if you need to for each bracket, break it down into its signs, which is going to be negative, variables, after we do the coefficient, so we should be negative 2w cubed. But if you want to do it all together, you can. So for example, you can go positive 10w squared. It's up to you. Whichever one's going to have you success. All right, and again, these aren't like terms, but they are in degree order. Okay, so you can't add or subtract them, do anything else with them. All right, last example here, folks, then we'll get into dividing. Let's just ignore that last arrow. I don't know why I did that. I wanted to do this is what I wanted to do. All right, and you don't need the arrows, so just putting them in so you recognize them as multiplying. Let's see if we can do this all together. So it's positive 2a to the fourth, okay, minus 8a squared. Next distributive law, it's going to be negative 12a, be careful here, to the fourth, okay, and minus 12a squared. All right, let's collect like terms. So how many a to the fourth we have? Negative 10a to the fourth. And a squareds, we have minus 20a squared. Reminder, folks, that these are not like terms, so you cannot add or subtract them. All right, let's get into dividing monomials. Again, you may not need to write this down, but continue to break it into the sign, the numerical coefficients, which ignores the sign because we've already done that part, so just kind of like the number part, and then variable and exponents. But when we do exponent law for division, when dividing powers with the same base, we subtract the exponents. So m to the a divided by m to the b is m to the a minus b. All right, let's take a look at these examples, and then I promise you we'll get onto some new stuff after. Okay? So what I would like, folks, is I would like to, if you can, get in the habit of showing me your exponent law. So first of all, the base is the same, and then you're going to tell me 10 subtract 7, which is b to the third. Okay, let's try the next one here. So k is our base, it's divide by, so you subtract the exponents, so you're going to have with k to the power of 2. Now, when you're dividing, you don't necessarily, when you've got a multiple of exponents, you don't necessarily show it because it's hard to break it down to its parts. So let's just show you what I expect here. Negative divided by negative is a positive. 24 divided by 3 is 8. Okay, f to the fifth subtract 2. It's going to be f to the power of 3. And g to the fourth subtract 1 is g to the third. Okay? All right, last example, and then we'll show you something new. Okay? All right. Take a look here, folks. If you don't like the division line, you can write it into like a fraction form, because this is what I like to do, so I visualize it so I can line things up. So I prefer this. Okay? So take a look at what I've got here, folks. It's easier when I have it lined up as a fraction, but you don't need to if you can follow it. Fine, that's okay. So a positive divided by a negative is a negative. 48 divided by 12 is 4. Okay, v to the fifth divided by nothing because there's no v there, so that stays at v to the fifth. W to the sixth, subtract 5, which is just w to the power of 1. And watch this. X to the 10th and x to the 10th, they cancel out because they're 1 each, so they will cancel out. Okay, if you're not sure about that, folks, x to the 10th divided by x to the 10th equals division law, which is x to the 10 subtract 10, which equals x to the power of 0. Remember, any exponent to the power of 0 equals 1. Okay, or you can just think about it as 5 divided by 5 equals 1. Okay, or b divided by b equals 1 as well. Okay, all right, on to something new, folks. Everybody ready? Dun, dun, dun. We're now going to be multiplying binomials. So in order to do that, this is new. When multiplying binomials, it is helpful to use this tool called FOIL. First, outside, inside, last. So I'll write this down. First means we take the first term in each and we multiply them. Okay? Outside, so right, don't need the other O. Let me back that up. So for outside, ladies and gentlemen, we take the two outside terms and we multiply them together. I'm just going to attach numbers to this, so give me that the second. I'm going to back up and put that one the first. Okay. Now we're going to do what's called the inside. So you're going to multiply those two together. So that's inside. And the last terms mean we're taking a look at the two last terms. So that's your fourth one there. Okay, so ladies and gentlemen, what this basically is instead of having a monomial out front where we use the distributive law. We have a binomial. The same rule applies. Everything out front of the bracket gets multiplied by whatever's inside the bracket. So we break it down. We do the A first. We multiply it by whatever's in the bracket, and then we do the B next and multiply everything that's in the bracket. And don't forget to collect like terms when possible. Sometimes it's possible, sometimes it's not. To get started, folks, we're going to focus on the arrows, and I'll show you how to do this. But by the end of this, you'll be fine. Okay, because it's not that difficult. Okay, so the first one, it's going to be a times a, which equals a squared. Okay, outside, we're going to multiply a times positive 4, which is going to be plus 4a. Okay, now we're going to multiply inside, which is going to be plus 2a. And then we're going to multiply our last, which is going to be plus 8. Okay, look to collect like terms. Notice that we've got 2 in the middle there that are common. So it's going to be a squared plus 6a plus 8. Okay, any questions with that? All right, let's try the next one without color coding it. Okay, so we'll still put the arrows in. So first is going to be w times w, which is w squared. Outside is going to be negative 7w. Inside is plus 3w. And last is negative 21. All right, first, outside, inside, last. Okay, and when we collect like terms, you're going to have w squared minus 4w minus 21. Okay, if you're wondering what the transformation of this is, folks, this looks like factored form, ladies and gentlemen, from the quadratic, and the final answer, so I'll just back up here. This expression here is in factored form of the quadratic, and we're going to tie this into this form, which is called the standard form of the quadratic. Okay, so we're going to tie that in eventually. I just want you to keep that in the back of your mind why we're doing this. Okay, let's take a look at C, folks. Let's do it a little quicker. So first is going to be negative 30. Outside is going to be minus 6r. Inside is going to be minus 5r. And outside is going to be minus r squared. When we collect like terms, we also want to bring the highest degree first. So we're going to go negative r squared. Collect your middle terms, which are going to be negative 11r and minus 30. We want to try to put it in standard form, which is the highest degree first. Okay. Now, ladies and gentlemen, we're going to go a little bit harder. Okay. And the last one will be quite a challenge. So what we want to do, folks, is realize we've got 2 sections of foiling here. First and second. We want to be careful here because there's a negative sign in between. So you're going to need lots of room here to do this. Okay, so let's do the first. It's going to be 15f outside, which is going to be minus 6f squared. Inside plus 35. And last is going to be minus 14f. Okay, that's the first one. Now what I'm going to do, folks, is I'm going to put this subtract sign in, which stays here. Okay, and because that affects everything in the second bracket, I'm going to put a bracket in. I'm still going to do my FOIL. So first is going to be 2f. Outside is negative 4f squared. Inside minus 2. And last, watch this, negative times negative is a positive 4f. Okay, you can collect like terms inside and outside the bracket before you multiply. I'm okay with that. I'm going to put this in a little bit more order. So I'm going to go negative 6f squared plus 1f plus 35. And then I'm going to collect like terms. Leave the negative out front. We're not done with that yet. It's going to be minus 4f squared plus 6f minus 2. Now we're going to apply the distributive law. So leave the first terms because you already got them in order as they are. Change the signs inside the brackets. And change all the signs, folks. Okay, now finalize your collecting like terms. So you're going to have negative 2f squared minus 5f plus 37. All right. Now this last one's a little bit of a doozy because it's a little harder than that one. Okay, because we've got operations to do as well, meaning I have a distributive law here. Okay, so just like before, we'll leave the negative 2 out front first. okay? Because we can do the distributive law after we've done the rest of the foiling. So let's foil this up. Let's try without the arrows this time. So we're going to go first, which is going to be 10d, outside, which is going to be minus 6d squared, inside, which is going to be plus 20d, and last, which is minus 12d. Keep the big bracket around because it's still minus by negative 2. Okay, next set, I've got a negative sign I'm going to leave out front. Now I'm going to FOIL these two. Okay, and you can use curved brackets instead of square brackets. I use the square brackets because the curved brackets already exist in the question. Okay, it doesn't matter as long as you've got it isolated. So let's do FOIL here again. So first is going to be negative 20d. Outside is negative 32. Inside is plus 5d squared. And last is plus 8d. Okay? Again, leave the negative 2 out front, collect like terms, and bring it in order. I'll just change it to a smaller bracket now. So we're going to have negative 6d squared. And then we're going to collect our d's. So it's going to be minus 2d and plus 20. Okay? Negative sign out front. Now we're going to collect our terms within the bracket here. So 5d squared, collect your d's, which would be minus 12d and minus 32. Now apply distributive law, ladies and gentlemen. So it's going to be plus 12d squared plus 4d minus 40. Okay? And then change the signs on all the last ones. So negative 5d squared plus 12d plus 32. Last step, we're almost done, folks. Collect like terms. So we're going to have 7d squareds plus 16d and minus 8 for your constant. Again, folks, that's a trinomial. It cannot collect like terms because they're unlike terms. Okay, so today, folks, we're starting in the algebra worksheet. Okay, so today you're going to look at worksheet number 1. That's at the beginning, and you're going to do only A, C, and E for all these questions. And then on worksheet 2, same thing, A, C, E for all those questions. And you need to look at the back of the booklet, folks, is the answers. Okay? Either the last page or the second last page. You're going to find the answers to these, okay? So, again, hopefully you enjoyed learning about FOIL and expanding binomials. And that's new. And again, if you need some help with that or any of the other stuff, please let me know. Have a great day, guys, and namaste.